Children, now let us get started with the 17th question, okay? So look, children, you just take a pause, read the question at least 2 to 3 times so that you will be understanding what I am explaining here, okay? So it was given that a pendulum clock when taken to the Mount Everest becomes fast. It means we are checking the time period. We are checking the time period here, okay? And next one is that the value of G is less at Mount Everest, means at a height h, okay? So if you look at this particular one, this comes under topic gravitation. This comes under gravitation chapter. Since here this is speaking about the time period, we have to say that this belongs to oscillation chapter. So mixing of both. Okay. So basic knowledge is gravitation. From that we have to find out the time period, that is oscillation. So let us check it. So how to find out the time period? So time period is given by T equal to 2 pi root over L by G. So what we want here is that relation between time period and G, that is acceleration due to gravity, like this. Okay. So now let us find out this G. So how to find out this G? From this gravitation concept, we have studied that at a height h is given by G into 1 minus 2h by r. This is what we have studied at a height h. Whereas at a depth d, we have studied that G into 1 minus d by r. Now these cases I am including here, I am explaining this question. Okay. So better take a screenshot. Now I am going to erase this. Now, pendulum clock when taken to Mount Everest. So, Mount Everest, nothing but it is at very height. Okay, at some height. So, we know that gravitation acceleration due to gravity at a height h is G into 1 minus 2h by r, like this. So, when this height h is increasing, what happens here is that when height h is increasing, what happens here is that this negative part is increasing. Negative part has been increasing, means this negative part is increasing. So the overall answer will reduce, no doubt in this. So GH is getting reduced. We can call it as G effective for our time being. Okay. So now this effective value of G is reduced. So the relationship between the time period and G effective is that T proportional to 1 by root G effective, like this. Okay. Now observe, my dear. Here this G effective has been reduced, so the time period will increase. So time period increase. What do you mean by time period increasing? What do you mean by time period? The time taken to complete one rotation. Increase in the sense it is taking more and more and more time. So this knowledge tells us that if time period is increasing, if time period increases, that means it is taking more time for the same work. Okay, it is taking more time, that is becoming slow. It is taking more time now. For the same work, it is taking more time. It means it is not rotating fastly. It is taking more time. It means it is not rotating fastly. It is going slowly. Look, if your parents tell you some work, okay, if you take a long time, what does it mean? You are not doing fastly. You are doing very slowly. So here, as per the given knowledge, given question is saying that rotating fast. Is it like that? So for mathematical proof tells us that it is moving slowly, not fast. So this statement is wrong. Statement assertion A is wrong. Now let us come back to the reason. Okay. The value of G is less at Mount Everest than its value on the surface of Earth. Let us check it out. The value of G is less at Mount Everest. So Mount Everest means nothing but at some height h. So G at a height h is given as G into 1 minus 2h by r. So this is our formula. Okay. So Mount Everest means nothing but at some height. So this is reduced. So the value of G is less at Mount Everest. Is it matching or not? Mount Everest is nothing but at some height, large height. He is saying that G has been reduced. Okay, clear? No, this G has been reduced. So we can say that this reason is correct. Less as Mount Everest than its value on the surface of Earth, right? On surface of Earth, the value of G is G only. Clear? So this G, since this negative value is increasing, what happens? This GH is reduced. So GH is less than G. GH is less than G because GH is equal to G into 1 minus something. So that 1 minus will reduce. So automatically GH will reduce. So the value of GH is less than G. GH means at some height, nothing but Mount Everest. So the value of G at Mount Everest is less than the value of G on the surface of Earth. On the surface of Earth. So the acceleration due to gravity at Mount Everest is less than the acceleration due to gravity on the surface of Earth. It means that our reason is correct, but our assertion is wrong. So A is not correct, but R is correct. So option 3 is correct. Option 3 is correct here. I hope you have understood this. With this, I have done with 17th question. Now let us move on to the next one.